Hi and welcome to another episode of TRX Bench. Today here again ICOM IC-735, and it is almost unbelievable how many of these units are still in the field. It must be a kind of love affair, I believe. But this unit is a little bit down. So the love affair is down a little bit, so vanished in the haze or so, and we have to try to bring back the old love. But seriously, so we have here a unit which is on different frequencies, on transmit and receive. So it has been told. So let's see if we can find the same, and then let's see if we can renew the love affair. Shall we? Okay, and here is our unit together with its power supply, and all is connected. Our generator is connected to the radio as well. So let's switch in. So power supply is coming up, and yeah, radio is on. So 14.1, generator is set to 14.1, but nothing. All is switched to FM. Generator is switched to FM as well, but no, nothing. Okay, and this is a kind of radio where we need a bridge here between antenna out and receiver in, so that it is split it off here, that you can put a transverter or whatever you can put here into this pass. So therefore we need, of course, here first of all a bridge. Okay, so let's try this. I mean, this is not for HF, that is for audio, but anyways, let's see if it works somehow. And okay, so we already see here a carrier, and wow, yes, it's working. I mean, it is definitely a wrong wire we are using, but you know, for our tests that will be fine, because we simply want to see if transmit and receive is on the same channel or not. Okay, and so first we want to do is we check if so we are here on FM 14100, and I just want to see if we push PTT, if we see then that the transmitter frequency is also on 14100. So let's go over to our communication tester. Okay, and you see we are receiving, so we are sending 14.1 megahertz into the radio, and that is what we can hear if we like. So here it is. So it is only low deviation which I'm putting in here, but that is just fine, no problem whatsoever. So let's simply go here to transmit, and let's see if one second. Oh, and let's simply see what we find here on our display. And oh yeah, so you see 7, so that means here 230 hertz off. Yeah, so that is too much, definitely. Okay, so but you know, on FM it is always more difficult to see. So let's go and change our mode to AM. Okay, so we are on AM. Radio is still receiving, so I'm sending with 50% modulation into the radio, and let's see the audio which is coming back from the radio, and that is looking fine, so no problem whatsoever. And you see when I'm playing here a little bit with the main dial, so here our feedback frequency is changing a bit, so that is looking fine, so no problem. And now the same test with transmit, and yeah, so 240 Hertz, and if that is still the problem on SSB, then you know that that is really a huge delta, which is not easy to handle. Remember, on SSB we would accept maximum 30% of delta frequency or delta offset, or however you want to call it, but yeah, 230, 40, whatever is definitely too much. And yeah, let me switch over, let me switch here my modulation off, and let me go to SSB, which we are, and you see already, yes, we have a signal here, and now it becomes more obvious, because as I already said, SSB is always much more complicated. And you see, now we do not only see it on receive, we also see it here on no, sorry, we do not only see it on transmit, we also see it on receive, and that is what you can see here. So I'm still feeding in here my signal with 14100, and you see that I am here 166 Hertz off, and that is only in receive. So for sure something is wrong here, and if we are lucky, it is really only a misalignment, and that is what we want to check next, and therefore we have to crack open our radio. Oh wow, and see what I found as well. I just wanted to start cracking here off the radio, and see this here. So we have here a loose connection, obviously, and let me directly go down that you can see it. So here we have our input, and I hope you can hear. Yeah, so for sure we have a loose connection additional to our frequency issue. So anyways, let's crack open here our radio, and then let's see what we can do. And of course, sure enough, the first what we need to do is to take care here on our loose connection. Yeah, and what we can already see, it must be a loose connection here, and you see how much it is wobbling here on the PCB. Yeah, sure enough. So that is really not the best news, because to get down here to the solder joints, we really have to take off here the complete PCB. And as you already can see, we have here a lot of wiring laying around, and that is what we need to take away. And yeah, then we can lift here our board and see that we get down here to our connector. Okay, so let me try to get it off here, and then let's see what we can find under our connector here. Yeah, and as you can see it here, we really have to take off all the connectors here, and I'm finally not sure if that is enough, because we have here a lot of wiring which is here going over the board, and well, additional to that, we have we have it with the harness here fixed to the board, and of course we have to take it away, and maybe I have to cut it here as well, just to see. And this here, I believe I have to cut this here as well. Looks like, yeah, now I can get it here away, as you can see, but still yeah, I don't know. Is it really all I can do here? Well, I have to get this here out of the way as well, but you see there is obviously still a lot of other connections here also. That is no fun. So let me try if maybe this is already enough. So now I take here our screws off, and I try to lift it here forward, that I can get access. Let's see. Okay, so all screws are out, I hope. Let's see if I can pull it back now a little bit here. And let's try if I can get it out here. And yeah, okay, so that is working. That is good. And have a look. Even with our microscope, we are almost not able to see it, but you see here is the crack. And when I now move a little bit here our connector, you see the pin is coming up and down, and that is clearly showing that we have here really open or loose connection. So let me go down here on the board so that you can see it here on the board, and only with the camera, so you see it is already moving out of focus. So that here, that is the connector, and yeah, we are definitely not able to see it bare eye, and we only see it here. You see clearly the crack here around the connector. So yeah, that is that happens over the years, and we see it very often with old radios, and sometimes you only recognize it only for a second or two, and then it is back working, and you never know, hey, what's going on here with my radio. And that is here very often what really happens to your radio, and therefore let's go and let's fix it. Okay, so first of all I clean it with some alcohol to get here really a clean solder joint. Let me see. Where is it? There it is. There it is. Okay. So that is now the first we do, and then let me fire up here my soldering iron, and then let's fix it. So no problem. Okay, first of all, of course, we put here some flux to our solder joint. Okay, that should be fine. Now let's produce a little bit airflow here from my solder. Temperature is given, so my section is working, and now let's see what we can do here. Yeah, I believe that is fine. Looks good, and we can go ahead. Okay, so I'm still cleaning it a little bit. I mean, it is normally not necessary because it is no clean flux what we are using here, but we have here some old rosin residue, so it is definitely not wrong to clean it, and a clean solder joint you can better see if the work you have done is good or not. And well, I'm quite satisfied here with the result, and now we can put back here our PCB into the radio, and then we really can go and search for our frequency delta issue. And okay, now we can flip it back over. By the way, I have also done here the other connections from our other connectors here. And now we need to get it here back in, and yeah, you see all the wiring is somewhat in the way. But yeah, we will get it managed for sure. So okay, our PCB is already back in, and yeah, let me put back here all the screws, and then I put back here our harness here, and wire harness, and then yeah, let's go ahead. Okay, so all connectors are back in place, and now of course we have to put new zip ties here to the wire harness, that we can fix it here as it was, and therefore of course we replace what we have cut off, of course. Okay, all is back so far, so let me put on here the button lid to the radio, and then we can flip it over, and now we need to open some more screws to get here to our main unit where we have to proceed. Of course, but first of all we want to know if we are really successful here with our repair, so let's see. And there is an additional problem here on the other board, so this is now good here, as we can see. So everything is fine. Let's turn it a little bit down. But maybe, or is it only here? Is it maybe my wire here? That there is now something additionally. So let me use here the red one. No, maybe that was the wire. Or? Not 100% sure. Maybe we have to check it as well. But down here that is fine, so no interruptions anymore. And here we will have a look if there may be. Or is it here? Let's check. Is it our antenna connector as well? Yeah, maybe that my screw here. Yeah, so that is obviously the screw here. Okay. So that is fine, that is fine. So you see sometimes, no, that is good, and down there it's good. So problem is solved, definitely. So that was only my connector here. Great. Okay, so now we can go ahead. So we were successful with this repair, and now let's go ahead. Yeah, and our PA unit with all the low-pass filters are here over the main board, and now we have access here to our main board where we have our frequency settings, and that is what we want to do right now. I want to check here some test points. If we see maybe that the frequency is off, especially from our reference oscillator or our reference crystal, and therefore yeah, let's go step by step. And what I want to do right now is following here our service manual. And I just want to check if these frequencies are okay, and when we are following here along. By the way, I have mixed up here the boards. So this here is not the main board. I mean, we have here our VCO unit and so forth, but it is not our main unit, so we have to flip it once again around, but no problem. So, alright, if we go ahead here, we can see that yeah, we have here PLL adjustment, and very interesting for us is here, of course, our PLL first LO, and especially, let me see where I have found it. Here we are. It is the second LO, which is very important, because we are working here on the receiver increment tuning. So you can see it here. So here switch on, switches on, and switches off, and we have two line on a pot here, our incremented tuning, and that is nothing else. The setting here that we can align here a little bit our receiver frequency, and again, if we take here, if we increase here a little bit here our audio, maybe like so, we have already recognized that our radio is off frequency, so that is what we saw when we did our first checks, and now you can hear it that I'm able here to align our frequency simply with our RIT pot here. And if this pot, so let me turn it down, so if this is misaligned, so normally it is here right in the middle, and if this is all misaligned additional to the other presets, then of course we have a delta between transmit and receive, so therefore we really have to go step by step, and we have to see if here a setting may be wrong, that we have this frequency error. Okay, and when we start here with our alignment procedure, so it all starts with general adjustments, of course. And well, the first what we need to do is here our BFO frequency. So that is already very important that these settings are accurate, otherwise you have all this frequency deltas, right? And well, so first what we have to do is to do here the setting, display to 14100, and yeah, CW keyer, CW keyer in, and set the electronic key switch to manual position. And if you have done all these settings, then you can start here with upper sideband on the main board, and connect the frequency counter to R158, and then we should read on upper sideband 9.0130 megahertz. Alright, so all the pre-settings at the radio are done, and you see that I have here connected our frequency counter, and when I go over, we see the following. So our first frequency should be 9.0130 megahertz. And you see that we are already off, and we are almost 300 Hertz off. And you remember our first tests we have done. We have seen that we have 200, what was it, 270 Hertz off when we switched to transmit. And you see that already our BFO frequency is 300 Hertz off almost. And that is only on upper sideband. So let me switch to lower sideband, which I have done now. So radio is now to lower sideband, and our test frequency, our BFO test frequency, should be 9.01 megahertz. And you see we are, what is it, 120, is it right? 120 Hertz approximately off. So that is LSB. And when I go to CW, so that is now CW, let me double check, yeah. And on CW we should see 9.00980, 9.0097600. So here we are 400 Hertz off. So you see, if we go really here along, we see, or let me check FM as well. So let me go to FM. Now radio is set to FM, and our service manual is saying that it should be 9. Oh, what is that? It is jumping back and forth. Yeah, that is interesting. That is interesting. So we do not get a reading here for any reason. So that is upper sideband. Ah, okay. So AM and FM has to be checked at transmit, and a second test needs to get performed as well. So let me show it to you. Okay, again, have a look. So what we have tested so far, and that is only in receive, is upper sideband, it is lower sideband, and it is CW on receive. And on receive we should read here our 9.0098, and that was off as well, 400 Hertz, I believe. And then of course now we have to check it on transmit as well, and FM and AM needs to be checked on transmit as well. But anyways, you see that the radio is completely misaligned. So that is most likely due to aging, and we really need to follow along here our whole alignment process, and that is really a very, yeah, let me say, it is time consuming, because you really need to do it very carefully, and you really need to do it accurate, that at the end of the day the radio is back in spec. And a radio with this age, believe me, that must be love, because otherwise it wouldn't make any sense, as it really consumes a lot of time. But anyways, let's go ahead and let's do here our alignment as we can see it here, step by step, and let's see if we are able to get it back into spec. Alright, so I've done here our first step, our first test point, and that is upper sideband. And according to our service manual, so we do not need to use this both digits. So that means what we see here is definitely the allowed tolerance. I'm displaying here this both digit, also we do not really need them according to the service manual. And that means because I'm displaying it and because I try to be as much as possible accurate, because these little trimmers, little cap trimmers are really touchy, and therefore you really need to take your time, alright? And therefore now this is the first setting for upper sideband, and now I will follow along, and you see that it is always a little bit jumping, which is normal in the last digits, because we only have here crystals, so normal crystals, so no TCXO or OCXOs or whatever, so it is only crystals, and therefore, you know, this accuracy what we have achieved by now is more than fine. Okay, so let me go ahead to the next test, and that will be lower sideband. So this is now set to lower sideband, the radio is set to lower sideband, and we need to get 9.0100, and that is what I'm going to align right now. This is now lower sideband, so that is what we needed to have, and now we go over to CW. So this is our starting frequency, and we need to achieve 9.0098, so that is what we need, so let's align it. Okay, and that is now our CW receive, and we go now over to CW transmit. Okay, and now I'm on CW transmit, so you see down there our output power, and we need to get the radio finally to 9.0, no, sorry, that's wrong. Where are we here? 9.01060. So let's try to achieve that. And that is now our receive, our transmit value. So you see, of course, it is a little bit jumping back and forth, and that is normal, as I told you already, but of course we try to do it even a little bit better, and that is just fine by now. Okay, and that is now transmitting on AM, and yeah, so we should set the radio to AM or FM. I've set it to AM because that key is lower on FM, so that is better for alignment jobs. So you see output power is only 0.19 watt, so radio will not get too hot, and so that is not too bad. So we should have here 9.01150, and you see we are pretty close, and yeah, let's see if we can bring it to where we need it, but I need another alignment tool here. Okay, and that is what it is, and once again our last two digits are our allowed arrow, so these both digits are not shown in our service manual, so we do not really need to care about it. Once again, if you have ever done it by yourself, you know that it is very, very touchy here, and therefore this is fine. Alright, we are going now over here to passband tuning. Oh, one moment. So you are able to see it. So we go now over to passband tuning. So we have done here all these steps, and we go now over here to passband tuning, and the control knob needs to be at the center, and we are testing here for this frequency, and we can align it with L78, and that is what we want to do. And then we check if we are within plus minus 500 Hertz. So that is the frequency we can vary with our passband control. And here at the radio we have here our passband control. So this little pot here, which we can move left and right, and in the middle it is a little bit fixed, so that you know that this pot is exactly here in the center position, and that is what we should do first. And now we have to check the frequency. Okay, so here we have it, and here is the frequency not so far away from where it should be. So we should read 94665, so that is not too bad. I'm increasing it a little bit, and here we are. So that's it. We can leave it exactly there. Okay, that means we are already finished here on the main board, and we have to go over to the PL unit, and therefore of course we have to flip over the radio to get to the button, or no, it's not the button, it's the top, and then we go ahead with our PLL alignment. All is prepared now for the next steps, and you see we are now here on the PL board, and of course a lot of presets needs to be done. So we really have to go to 79999, and it has to be on AM. And you see already on the board that I'm here at our test point, and we are aligning the PLL, and we are testing here for DC voltage, and well, so therefore our meter is already connected, and we should read here 1.2 volt, and you see we are a little bit off here, and we have to align it. And so first what we need to do is to open here this little box, and we have here our sub PLL circuit, and our coil, which we need to move a little bit, is this here down there. So by pulling it apart or pressing it together, we can change our voltage, and as I told you, we need to have here 1.2, and this here is a very important and crucial setting, because if the sub PLL circuit is not adjusted in the right way, you get white or however you want to call it, black areas on the band or over the band. So you're tuning and you are able to hear stations, and suddenly there is only noise, and that means you have dead areas over some bent areas, and that is due to the fact that this here is aligned simply in the wrong way, and therefore this alignment is very crucial, and we have to do it very carefully. And again, we have to set it to 1.2 volt, and I try to achieve it here now by pulling here it a little bit apart, and you see that our voltage is changing, and I hope I can get it to 1.2 volt. And alright, so that looks pretty nice. You see it is still moving a little bit, so that means we can do here a bit more. But again, you can see how sensitive this is here. And now we are a little bit too high, and I try to correct it here a little bit. I mean, you do not need to bring it to a millivolt area, but to have this here more or less accurate means you do not have to fight with this areas, and yeah, so that is where we can leave it, and I've nothing done but moving here the coil with this ceramic screwdriver very carefully to achieve here my 1.2 volt, and back here to the meter, back to the coil. So you see that is exactly what we need. And now I have to change my frequency on the display, so I need to bring it to 8 megahertz on AM, and that is what I will do. And watch here our voltage, because now this is 8 megahertz, sorry. And now this is already the next setting. You see we are now at 2.9 volt, and that is off again a little bit, and we have to bring it down to 2.5 volt. Here you can see our steps we are currently doing. So we have put here our 1.2 volt by changing the width of our coil in the sub circuit, and now we are here at this point, and you see it is at 2.9, so that is a little bit higher. So that is not that critical, because if this is fine, that is important, everything is good, and we should minimum achieve 2.5, and we are at 2.9, and we can leave it. So you see, you have to do it very carefully. Important is now when I go back to 7999 megahertz, as I'm doing it right now, we need to get back to 1.2 volt. That is very important. And now up to 8 megahertz, and you see it's going up. And now we have exactly the entire range which this sub-circuit is able to adjust. So that is what we need to check here. And once again back to 79999, and we are back at 1.2 volt. So that is working very fine, no problem whatsoever, and therefore let's go ahead. Next is we have to check, and maybe we have to align the output voltage, so that is the LO output. So we need a certain power that the mixers all will work as they should, and therefore we have finally to check here for minimum 40 millivolt RMS, and we are here really on the HF side, so we need an RF voltmeter, millivolt meter, to check here for our 40 millivolt RMS. Therefore we have to go down to this IC down there at pin 5. We will check for minimum 40 millivolt, and it should be even better, so therefore let's go up to our instrument. Therefore we use our trusty millivolt meter from Rode and Schwarz, and let me go down here to pin 5. So I have to count 1, 2, 3, 4, 5. So that should be pin 5, and you see we reach 87.9 millivolt RF here at this point, and minimum is 40 millivolt, and that means we do not realign, because our service manual is clearly telling us that 40 millivolt at least, so that is minimum, okay, and therefore everything is fine. So next, what I've already done is our VCO setting, and you have to go through all these different frequencies, and you need to check here for 6.5 volt, and you have to adjust it to that voltage with our caps, our variable caps, and that needs to be done down here. Here we have our VCO, and here is our test point, and that is the voltage for our last step on 30 megahertz, and we have to align it to 6.5, and 6.51 is just fine. So you do not need to bring it absolutely to 6.5, and if you see your service manual, then you recognize that we only get 6.5 without additional digit, and that means that if it is showing 6.5, forget about the rest of the digits, and that is exactly what I've told you. When I did, for instance, a review here on our Cyclant, so you really do not need too many digits, so more resolution sometimes means more confusion, and therefore you do not really need more digits than this Cyclant, for instance, is delivering, and therefore that value, what we can see there, is fine. I've already done the rest 4 settings, so we can go ahead. And you can see now we really have to adjust our first LO. And now it all is about checking for frequencies and setting the frequencies on the right point. And you see here, for instance, we have to align to 100.45 150 megahertz, and obviously here we need to have a little bit more resolution to get this setting accurate, and therefore now I go and connect my frequency counter to J13, and of course we have to do here all the pre-settings, and we are already on 30 megahertz and we are already on AM, because that was the same what we had here with our VCO setting, PLL VCO setting. And of course, so we start with 30 megahertz, and let's see if we need to realign our 145 150 megahertz. And down there we have our test point. So I'm picking here our signal, and yeah, let's check if it is on the right frequency. Okay, so here we have our frequency 104.50934, and according to our service manual it has to be 104.5 150, so that is slightly off, and let's try to get it a bit better to 150. You see it is moving, and let's see what we can get here. Let's see, 150, and the last digit is not important what we see on our counter. It is already just fine, as we really need to have it, and therefore I leave it alone, so that is just fine. The service manual is now asking for verifying if we change our display frequency to 100 kilohertz, and that is what we want to do, and we need to have then 70.55150 megahertz. So I am now switching over, I'm dialing over to 01 megahertz, means 100 kilohertz, and perfect. That is exactly what we need. Again, we do not need to take care on the last digit on our counter, so therefore that is perfect. The next important check is again here at our G13, if the level we get out of our first LO is on the right level, and we expecting minimum 400 millivolt RMS. So that is tested without termination, so that is simply an voltage measured with high impedance, and therefore let's go back to our trusty millivolt meter. And here we have it. So we have 621, if you will, millivolt out of our J13. Minimum should be 400, so that means that our LO power, let me call it power, is strong enough for the mixing process. Everything is just fine here. Now we are already on our LO2, and we are picking, can you see it? I don't know, down there, that is J4, so that is the output from our LO2, and of course again we need a certain output level which we need to check, and we need to have 700 millivolt, and let's check if we are fine here. And there we have it. So we are over 700 millivolt. That means LO power is just fine. So now we can go and check for frequencies, and we stay of course at J14. And now we need to check if the frequency setting for our LO2 is correct. Now it is important to have this here on mind, our incremental tuning, so that we can pull the frequency a little bit. So therefore you see we have to switch our read switch on, and then we have to check here for 6144,000 megahertz. And once again, it's very important to switch read on. All right. Okay, so you can see here our read is switched in. So now it is out. Now it is in, and I've tried here to set our pot to the center, where we should be able to read the right frequency. And as we can see, we are out a little bit. So we try to get it to 6144,000. And let's see if that works. Can we move it up a little bit? 244. So that is quite a bit, as you can see. And let's go back here to a bit maybe. So we have 1, 2, 3 zeros. 1, 2, 3. So again, that means that the last digit we can see on the counter is not important, so we can leave it alone. But to have it right in the middle, like 5, is very nice. So that's it. It's working fine. Okay, the next setting is very important. You see, we have to change here our display frequency, and now we have to switch off our incremental tuning, and we need again with a different display frequency, we need exactly the same output frequency, and we need, if it is not on the right frequency, we need to align it with R17, which is a little pot on the front panel. And yeah, I show you where it is. Okay, so let's try to zoom in, and you see there we have it. So that is the pot where we need to go for our 6144,000, and that is very important that we do not have the delta between transmit and receive. So this setting again is very crucial, and therefore let's check. Okay, and here it is. Not too bad, but again we need 3 zeros, and therefore we need to align this pot a little bit, so that is a little bit difficult to get to, so that is not so easy. So yeah, let me try to find here the right tool to get down to the pot I've shown you, and then we try to bring it down to 0, 0, 0, 0 at least. Yeah, that is a little bit tricky. I have here a tool what I was able to bend a little bit to get down here to our test point, and now you see I'm able to dial it in, and as you can see, I mean that would be fine at least, but again I try to get it here a little bit better, but it is difficult here with the tool. I have a little bit trouble here to get here to the pot. That is could be better. Yeah, you see it is always jumping back. That is again yeah, okay, so maybe now no, bit more, come on. No, this pot doesn't like me. No, unbelievable, come on. Okay, so we leave it. That's just fine. Great. And I really was using here a plastic tool that I was able to get down here to the pot because you know, here my PA unit is simply in the way, and yeah, otherwise I would have moved it around, but therefore here our wiring is too short, and oh, that is all a little bit tricky here, but anyways we have it now exactly on the right frequency, just fine. Okay, so let's check now here our frequencies, if we still have after the alignment the same delta. And you see I'm sending in here, so that is now the generator frequency, and of course we can hear our signal, and you see the sign, which is very nice. And when I now go to transmit after the alignment, we should not see this huge delta, right? So that means, let me push here the button. Yeah, that is great. Have a look. So we are more or less on exactly the same frequency. Well, there is really no big difference, and that is exactly what we want to see. So that is great, and that means our alignment here was totally successful, and therefore great. Alright, so radio is still here receiving, so let me turn down the tone. So that was a complete receiver alignment, and you see it was quite a bit, but it was successful, and the only thing I have to do now is to put back here the housing as it have to be. Here, put our PA unit over it, and so forth and so forth. But finally, this is the end of our video. Well, as always, I hope you learned something, and this radio goes back to its owner, and yeah, thanks for watching, and catch you next time. Bye.